Hey guys, as promised, I'm here to make to go over some of the answers from the Trig Circuit. My printer's having some trouble, so I am just going to go old school with some scratch paper and just go over some of the most requested problems. I'm going to go over 4 problems. I'm going to go over not labeled by like the order of the circuit, but by the picture where I labeled them. I'm going to go over number 3, number 7, number 8, and number 16. All of those questions were requested more than once. Thank you to all of you guys who took time to do the circuit and fill out the Google form. I hope you guys find this helpful. Even though I'm not in person with you, it's kind of nice to do a little pre-calculus and be able to do a little math with you guys. So let me just jump in. The first one was number 3, which was 2 secant squared of theta equals 2. So we're going to solve this for theta on the interval 0 to 2 pi. Okay, so I'm solving for theta. I want to get theta by itself. So I'm going to start by dividing by 2 on both sides. That's going to give me secant squared theta equals 1. We have a couple things that I could do next. I'm going to take the square root of both sides next. So when I do that, I'm going to end up with secant of theta equals plus or minus. This is important. Remember, when you take the square root of both sides, we need that plus or minus in the front. So plus or minus 1. And then we want to remember that secant is the reciprocal of cosine. So if I want to turn this into a cosine problem, I'm going to, or we can think of it this way. This is the same thing as 1 over cosine of theta equals plus or minus 1. So if I want to flip this and find the reciprocal and just get cosine of theta, I'm also going to need to take the reciprocal of this. Well, if I have 1 and I flip it, I'm still going to have 1 over 1. If I have negative 1 and flip it, so I have 1 over negative 1, I'm still going to have negative 1. So cosine is going to be equal to plus or minus 1. So I'm just looking for all the places where cosine is either positive or negative 1. Well, at 0, cosine is 1. At pi, cosine is negative 1. And at 2 pi, cosine is 1 again. So there's my answer for that problem. I hope you found that helpful. I'm going to jump and do number 7 now. I think this is one of the harder ones. So let's give this one a go. This problem starts with cosine squared of theta equals sine squared theta plus 2 plus 3 sine theta. Okay, remember my goal again is to solve for theta on the interval 0 to 2 pi. Because I have squared terms, I have sine, and then I also have a constant, I'm probably going to need to factor this at some point. And the easiest, we want to do that after we only have sine or cosine terms. Well, you'll notice that I have both sine and cosine terms that are squared, but I only have a sine term. I don't have a cosine term. So it would be best if I can get everything in terms of sines. Unfortunately, I can replace that cosine squared with my Pythagorean identity. So as a reminder, we know that sine squared theta plus cosine squared theta equals 1. So if I want to replace this and I want to get this cosine squared by itself, I can subtract that sine squared to the other side, and I'm going to take this identity and then plug it in here. So when I rewrite this, what I really have is 1 minus sine squared theta is equal to sine squared theta plus 2 plus 3 sine theta. And hopefully a lot of you guys from this step could keep going, but I'll keep going through the problem. I want to get 0 on one side before I factor, so I'm going to move everything onto this side so that my leading sine squared term will be positive. So I have 0 over here now, which means I'm adding sine squared, which will give me a 2 sine squared on this side, plus 3 sine theta. I'm going to subtract this 1 onto the other side, so I'm going to have 2 minus 1, so I'll have a 1. So now I can factor this. If it's helpful as a reminder, you could think about this as, so if sine is my thing that's being squared, what I really have is 2 of something squared plus 3 times that something plus 1. And that's what we're going to factor. Okay. I need to multiply to 2 sine squared. So I know my only option for doing that is having 2 sine theta times sine theta. I also need to multiply to a positive 1. Well, the only 2 options for that are positive 1 and positive 1, or negative 1 and negative 1. Since they need to add to this positive term in the middle, I'm pretty confident I'm going to have a plus 1 and a plus 1. So if I start FOILing this out, I'll get 2 sine squared, 2 sine theta plus 1 sine theta. That gives me 3 sine theta, and then these multiply to give me 1. So this looks good. Remember, I'm solving for theta. So now what I'm really asking is, when is this equal to 0? And when is this equal to 0. I can only use this process when I'm factoring with 0 on this side. If you factor this and put 1 over here, you're not figuring out when each of these equals 1. Because, for instance, the value of theta that might make this thing 1 might make this over here something like 3 or 4 or -1. And if you multiply those things together, you wouldn't be getting 1. But if I have 0 on this side and I can make either of these things 1, anything times 0 is 0. And that's why this process only works when I have 0 on this side. Well, I'm going to skip a couple steps here and say if I isolate sine of theta, I'm going to have a -1/2 on that side. And over here, if I want to isolate sine of theta, I'm going to have a -1 on this side. So my last step is to ask the question, for what angle, if I plug it in, do I get sine of that angle is -1/2? Well, I know that my reference angle for this is going to be pi over 6, and I'm going to be in the third and the fourth quadrants. So that's going to give me 7 pi over 6 and 11 pi over 6. Over here, I'm looking for where's the place where sine of theta is -1. Remember, sine is going to represent the y coordinates on our unit circle, so it's asking when am I at the bottom of my unit circle, and that's at 3 pi over 2. So there's my answer for number 7. So again, remember, we're going through number 3, number 7, number 8, number 16. We just did 3 and 7. I'm going to now jump to a new piece of paper, and we're going to do number 8 and number 16. Okay, so number 8 is solve 0 equals cosine of 2 theta plus cosine theta. And I realize that on a couple of these, including this one, I forgot to explicitly mention that we're solving on 0 to 2 pi, but that's normally assumed unless it's stated otherwise when I solve trig equations, at least for now. Okay, so let's give this a go. I need to solve this, and I noticed that I have this double angle formula, or this double angle. I can replace that with its identity. The primary identity that we use for double angles for cosine is cosine squared minus sine squared. So the first thing I'm going to do is replace that. Like the last problem that we just did, we had the problem where we had both sine squared and cosine squared terms, and we'd like to get all of this into only sines or cosines if we can before factoring. So I'm actually going to replace this thing here with my Pythagorean identity. So if I want sine squared, that's going to be 1 minus cosine squared. Now do be careful here. When I replace this, I'm replacing this with 1 minus cosine squared, but I need to subtract that whole thing. Just like I'm subtracting sine squared, I need to subtract something that has an equivalent value. That negative is going to need to be distributed. Okay. So if I simplify a little bit, I now have cosine squared minus a negative cosine squared, so 2 cosine squared. I have a plus cosine theta, and then I also have a minus 1. Just like before, I'm going to need to factor this. If you need to rewrite this before you factor, you could rewrite this as 2y squared plus y minus 1. You could use x's in this case as well. Because x isn't already part of the problem, it'd be okay to use that over here. So you could also have 2x squared plus x minus 1. But if it helps you to factor in this form first, you definitely can. So now I'm going to factor. I have a leading term of 2 cosine squared. So 2 cosine and cosine will be my leading terms. The only way to get to -1 is to multiply 1 and -1. We just need to figure out which one goes where. Since this is a positive cosine term, I'm going to put the positive 1 to be multiplied with the bigger term, the 2 cosine theta. That'll give me a 2 cosine theta. And if I put a minus 1 here, that'll give me a minus 1 cosine theta. When I add those together, that'll give me cosine. So then just like before in the last problem, I want to ask the question, when is this equal to 0? Well, I'm going to solve that quickly and say that's going to be when cosine is a positive 1/2, because we'd add the 1 over and divide by 2. This is asking the question, when is cosine of theta equal to -1? Remember, we want to know when this factor is 0, so I just solved that for cosine. So if I want to know when cosine is 1/2, well, that's a reference angle of pi over 3, and cosine is positive in the first and fourth quadrant. So for this problem, I'm going to get pi over 3 and 5 pi over 3. And then we want to know when cosine is -1. Well, remember, cosine represents the x-coordinates on the unit circle. So I want to know when I'm all the way to the left, and that's going to be at pi. Okay, so that's your answer for number 8. Or in other words, the bottom problem on the right on the front of the piece of paper. Okay, and And now lastly, we have number 16. That's the last one that multiple people asked for. So let's give that a go. This was sine of 2 theta equals negative sine theta. First thing I want to do, again, remember we're solving this on the interval 0 to 2 pi. I want to replace my double angle with 2 sine theta cosine theta. That's just a trig identity you need to know. Now, as a reminder, we don't want to divide both sides by sine of theta because then we're taking out possible zeros for this problem. So instead, I want to get everything on one side. So I'm going to move everything over here. I would rather move everything to this side to keep it positive, but you can do it either way. Once I have it all on one side, I notice that I have a GCF of sine of theta in both of my terms, so I'm going to factor that out. And that leaves me with this. Remember, I take sine of theta from itself, I'm left with 1. So this is asking the question, when is sine of theta equal to 0? I'm also asking when this whole thing equals 0, but if I solve that for cosine, I'm going to get a negative 1/2. Okay, so last thing I need to do is figure out when this is true. So sine of theta is 0 at 0 pi and 2 pi. We already talked about this a moment ago. Cosine is 1/2 at a reference angle of pi over 3, and it's negative in quadrants 2 and 3. So this is going to give me answers of 2 pi over 3 and 4 pi over 3. Okay. I hope you guys found this helpful. Again, I know I didn't go through everything you guys requested, but all the ones that multiple people asked about. Just some things that you might want to check on if you had trouble with other problems. Make sure you picked the right reference angle, got the right quadrants right for negative and positive. I would make sure you never divided by a term on both sides, but rather subtracted over and factored. Make sure when you square a root, you put a plus or minus. So hopefully that's helpful and will help you fix your other problems, but feel free to shoot me an email if you still have questions. And I'll talk to you guys soon.